What if a single drone could slip through every defense and erase a military aircraft in minutes? At 1347, on January 25th, 2026, the Black Sea surface was calm. Too calm for what came next. 6 Ukrainian UJ-26 drones broke free from the wave tops west of Crimea, sliding forward at barely 15 meters above the water. Their silhouette was swallowed by sea clutter. They moved at an unremarkable 190 kilometers per hour, slow enough to look harmless, steady enough to look intentional. This was not reconnaissance. This was the opening strike. Each drone held formation for exactly 42 seconds. Then, they compressed their spacing to less than 120 meters between airframes. No radio chatter, no GPS pings, no electronic noise to give them away. From a distance of roughly 39 kilometers, they aimed directly at Kacha Air Base, north of Sevastopol. This is one of the most watched pieces of airspace in the region. Inside a Pantsir S-1 combat vehicle, the atmosphere was heavy with heat and tension. Cooling fans screamed and screens flickered. The fire control radar painted something that should not exist. Contacts that appeared solid for half a second, then dissolved into static. Not missiles, not aircraft. The system tried to classify the targets, but it failed. The drone's composite airframes and absorbent coatings fractured their radar return into fragments. Sometimes registering as a light aircraft, sometimes as nothing at all. Flying so low, they blended perfectly into the sea's natural noise floor. To the software, they were anomalies. To the operators, they were unease. And here was the uncomfortable truth. The drones were not searching for targets. They already had one. Parked inside Ketcha, a single AN-26 transport aircraft worth tens of millions was selected days earlier. It was critical for logistics. The drones were simply executing a pre-written path toward it, minute by minute, meter by meter. At 1348, the most expensive air defense systems in the region were already reacting late. The real attack had not even begun yet. At 1350, 2 of the 6 drones peeled away from the formation. They pitched sharply upward, climbing through the cold air at nearly 6 meters per second. In less than a minute, they reached an altitude of 2,250 meters, far above the sea clutter that had protected them moments before. To the operators inside the Pantsir S-1, this sudden ascent looked like escalation. An escalation demanded a response. As the drones climbed, their signatures changed violently. What had once been faint radar echoes suddenly inflated. They ballooned in size, intensity, and threat level. On the fire control screen, 2 modest contacts swelled into objects comparable to medium bombers. The radar cross-sections amplified by more than 900 times. To the system's logic, these were no longer minor intrusions. They were priority targets. Turrets slew upward as hydraulic systems screamed under load. The operator's finger pressed the launch command twice. 57 E-6 interceptors erupted from their canisters, accelerating past Mach 3.7 almost instantly. Each missile cost more than $100,000. But cost was irrelevant now. Stopping the threat was everything. High above the coastline, each missile detonated within meters of its target. They released dense rings of tungsten fragments. The 2 drones vanished in white flashes. Their destruction was clean, decisive, and deeply satisfying. On the screen, the massive radar contacts simply disappeared. Inside the vehicle, someone exhaled for the first time in minutes. What no one realized was that those drones carried no cameras and no explosives. They were flying decoys, lightweight frames filled with extra fuel and signal enhancement hardware. They were designed to die loudly and expensively. As smoke drifted away and the radar system reset, a far more dangerous picture was forming. While the Pantsir celebrated 2 kills, 4 real drones were racing in at 12 kilometers. They were spread wide, low, and silent. The system that had just fired its first shots was about to face a problem missiles could not solve. At 1402, the remaining drones continued forward at a steady 180 kilometers per hour, flying low enough to stay beneath most optimized tracking envelopes. Their behavior was calm, almost indifferent. They were guided by inertial data and visual reference, rather than any external signal. They did not maneuver aggressively. The S-400 battery assumed control of the engagement. A launch authorization was granted. Moments later, a long-range interceptor ignited and climbed violently. It accelerated into the upper atmosphere. The missile's guidance system locked onto one of the drones. It held the target steadily through successive radar sweeps. Unlike the short-range systems below, this was an intercept designed for certainty. The missile detonated precisely at its calculated point. The drone was destroyed instantly, its structure torn apart mid-air. Fragments scattered outward and fell harmlessly away. On the command screens, the track vanished. The kill was clean, verified, and undeniable. But the interception achieved something else, something less visible. For several critical seconds, radar focus narrowed. Fire control priorities shifted. While attention remained fixed on confirming the destruction, another drone slipped past. It flew through the engagement zone, lower and slower than any model had anticipated. By the time the system reacquired the airspace, it was already too late. The surviving drone descended toward the interior of Kutcha Air Base. Skimming over service roads and storage areas, its final guidance mode activated automatically. Visual recognition replaced navigation. The onboard processor scanned rectangular shapes and shadow patterns. It searched until it found a match. A hardened storage hangar. Inside, an AN-26 transport aircraft sat parked and partially fueled. It was surrounded by maintenance equipment and spare containers. The hangar doors were closed and the aircraft was presumed safe. The UAV accelerated slightly, stabilizing its descent. Then, it rammed straight into the hangar, smashing through the outer structure and detonating at the heart of the enclosed space. The explosion did not bloom outward like a fireball. It expanded inward, with pressure rebounding off concrete and steel. This multiplied its force. Fuel vapors ignited instantly. Internal supports failed in sequence. The AN-26 was struck not by shrapnel alone, but by a collapsing environment. The structure designed to contain violence was now turning it inward. When the smoke settled, the hangar was no longer intact. The AN-26 inside was no longer operational. The interception had succeeded, and the defense had fired perfectly, but the attack had never depended on a single path. The failure had already begun quietly and invisibly, inside the logic of the network itself. The first contacts appeared far offshore, at a distance of roughly 37 kilometers, drifting just above the Black Sea surface. On the radar scope, they were unstable and flickering, their signatures fragmented into meaningless data. One sweep suggested something the size of a light aircraft. The next reduced it to background noise. Then it vanished entirely.
What is your status, radar?
To the radar, the numbers made no sense. The objects moved at 185 to 195 kilometers per hour, slower than a jet, but faster than most civilian craft. They were far too consistent to be debris. Their altitude stayed below 20 meters. This was low enough to merge with wave reflections and coastal clutter. The system's filters were designed to eliminate false positives. They did exactly what they were programmed to do. They erased the targets. Inside the command vehicle, operators leaned closer to their screens. This was not a malfunction. Diagnostic checks returned green across the board. Power levels were stable, antennas aligned, and software current. The radar was working perfectly. That was the problem. Modern air defense systems are trained to distrust ambiguity. Anything that behaves inconsistently is assumed to be noise or weather. These contacts behaved too inconsistently, and it was intentional. Composite airframes and irregular outlines fractured the radar return. The pieces were small enough to fall below engagement thresholds. For several critical minutes, the drones existed in a blind zone. It was not a blind zone of distance, but of belief. Manual lock attempts failed. Each time the operator tried to force a track, the system rejected it. It reclassified the object as sea clutter. To the software, engaging such targets would have been a mistake. It would be wasting missiles on nothing. So, nothing was done. By the time the contacts triggered alarms, the drones were already too close. Their approach vectors were locked in, and their paths were irreversible. What followed was not the beginning of the disaster. It was simply the moment the system realized that what it had been ignoring was real. When the threat could no longer be ignored, it multiplied. As the surviving drones pushed inside 14 kilometers, they dispersed. In less than 3 seconds, their formation collapsed into a wide fan. One veered north, one south, and 2 drove straight toward the center. The maneuver was simple, almost crude, and it was devastating. The Pantsir S-1 radar tracked all of them. Technically, it could follow up to 20 targets at once. Every contact was visible, and every vector clear. But engagement was another matter. The system possessed only 2 active fire channels. It had only 2 hands to respond to 4 incoming threats. The operator hesitated, then escalated. A secure line to the higher command node crackled to life. Target data was shouted, repeated, and corrected. Bearings conflicted, and altitudes were misheard. In a digital battlefield built for milliseconds, coordination fell back on human voices. The exchange consumed 28 seconds. In drone warfare, that is an eternity. A nearby Book system attempted to fill the gap. Its radar switched rapidly between targets, illuminating each drone in sequence. The process took roughly 480 milliseconds per cycle, but during each gap, the missile flew blind. It relied on predictive mathematics rather than observation. The drones exploited that gap without ever knowing it existed. Their guidance scripts introduced irregular movement, brief climbs, sudden drops, and shallow turns. Deviations of just 20 to 30 meters were enough. When the radar returned to a target, the missile was aiming at where the drone had been, not where it was. One interception succeeded, barely, when a drone held a straight path for too long. Another missile burned out mid-correction, expending its energy in empty air. The scoreboard shifted. One drone was destroyed, but several were still advancing. What failed here was not range, firepower, or detection. It was synchronization. Systems built to operate flawlessly in isolation were now stepping on each other's timing. They were constrained by physics, software cycles, and human delay. By the time the sector attempted to reassert control, the drones had crossed the line. They were past the point where layered defense was supposed to overlap. From this point forward, there would be no margin left to recover. When the noise finally faded, what remained was not chaos, but silence. Inside Kacha Air Base, systems rebooted one by one. Power returned unevenly across sectors. Radar consoles glowed again, displaying empty skies. Minutes earlier, warnings had stacked faster than operators could read them. The engagement had lasted less than 13 minutes, yet it had drained years of confidence from the defensive network. The numbers told a brutal story. Multiple interceptor missiles had been expended. Each was valued between $90,000 and over $2 million. They were used against targets whose individual cost barely reached 5 figures. Fire control radars had tracked and classified the same airspace dozens of times, yet they failed to maintain a continuous picture when it mattered most. The defense had not collapsed from lack of technology. It collapsed from too much specialization. Every system had performed its role correctly, just not together. Short-range units excelled at fast, obvious threats. Long-range systems were optimized for speed and altitude. Medium layers depended on perfect timing and clean data. The drones exploited the seams between those layers. They moved slowly where speed was expected. They hid where clarity was assumed. And they attacked where protection felt guaranteed. The destruction of the AN-26 was not a tactical accident. It was a strategic message. Hardened shelters and automated response chains were built around predictable danger. The attack succeeded because it rejected predictability entirely. No overwhelming force had been required. No advanced stealth fighters or grand-scale electronic jamming, just inexpensive airframes and preloaded logic. Environmental interference and the certainty that modern defenses trust filters more than instinct. By the time damage assessments were complete, the conclusion was unavoidable. The air defense network had not been defeated by superior firepower. It was defeated by a form of warfare that moved beneath its assumptions. The sky over Kachcha was clear again, but the belief that it was secure had been permanently erased. When the smoke cleared, the sky looked empty again, but nothing was the same. This battle was not decided by who had more missiles or faster radars. It was decided by who understood the limits of those systems. A handful of inexpensive drones exposed the gaps where confidence had replaced caution. where automation had replaced judgment, and where speed had become a weakness instead of a shield. The destruction of the AN-26 was a warning. Modern air defense is built to stop what it expects to see. The moment the threat refuses to behave as predicted, the network begins to unravel. If you were responsible for defending that base, what would you change first? The technology, the doctrine, or the way decisions are made? Share your thoughts in the comments. If this analysis gave you a new perspective, don't forget to like and subscribe. Join us for the next story where technology meets its limits.